Hello everyone, and welcome to the NEATEC Electronics Series. This video is about counters, so let's get started. Hello everyone. So up to this point, you have been given a circuit, and now you know how to analyze it to determine how it progresses through a series of counts, and then obviously you can determine if it recycles or not and where it goes to. Okay, so now we are going to start where we are going to design a counter and then create a circuit. All right, and you have to go through a series of steps for this. All right, so the first thing, now in many textbooks you're going to see a list of specific items you want to perform, right? Generally you want to define what you want to do, okay? Then you're going to draw a state diagram, because that's a visual representation of how you want it to progress through the counts, right? Then you're going to want to make a state table and partially fill it out, and you'll understand this when we go through it. Then you're going to have to use your excitation tables to completely finish the synchronous input section of the state table. Then once you have that done, you need to simplify each of those variables, the J and the K, for each flip-flop you're using. All right, from the state table using Karnaugh Maps. From the Karnaugh Maps, you basically will get an expression, all right, which you can turn into a circuit. It's going to be an expression in terms of your Q outputs, all right, and then your output will be a counter, right, as you designed it. So I'm going to go through this in one of the simplest, I say simple, nothing simple, please don't misunderstand that part, but let's go through this in a very basic way. Let's just create a counter that counts from 0 to 3 and then returns, okay? So if we're going to do that, let's just do this. So it's going to start at 0, right? There's 0. And we're going to go to 1, and we're going to go to 2, and we're going to go to 3, and then we're going to go back to 0. Now, if you recall, for a state diagram, each one of these states has a circle around it. Alright, there we go. Now, what else do we need? We need to have an arrow pointing to where the transition, what state one state transitions to, right? So 0, 0 will transition to 1, 0, right? 1, 0 will transition. Let's just write this down. So this is 0, right? This is 1 in decimal, but it's 1, 0 in binary. This is 2, or 0, 1 in binary. This is 3, or 1, 1 in binary, and it comes back to 0, right? There is your state diagram. All right. Now we need to make a table, right? State table. So suppose, let's take this and come over here like this. I'm doing this real time with you, so I'm going to try to make this as pretty as I can, but I can't guarantee it's going to be beautiful. this over here for you. So this is going to be your present state. This is going to be your next state. And these are going to be your synchronous inputs, okay? All right? So this will be Q0 and Q1 present. And this will be what? Q0 and Q1 next. What do we have here? You know what? I'm drawing these backwards. I'm going to do this one. That's J1. Sorry about that. Let's just take that out of there. And this will be K1. And this will be J0, K0. All right? Now, we haven't filled it in yet, have we? So let's see our present state. We're going to start from 0, 0, right? So if we're starting from 0, 0, if we look over here, right, we're going to see, we're starting here, right? Right there. We're starting here at 0. Our next state, if we follow it, is going to be right here, isn't it? It's going to be 1, 0. Got it? So our next state is going to be 1, 0. All right, very good. Now, how did we get there? We have to fill in these JKs for this, all right? But you know what? Let's just let's do that next. Let's just continue filling out the present and next, and then we're going to do that. But I want you to think about this when we're doing it. Each one of these transitions, Q0, for example, has to transition from 0 to 1 when it's clocked, right? But Q1 has to stay on 0, right? So you just think about how we're going to do that. But anyway, let's go. So the next state here is 1, 0. We're going to copy it down. What's after that? 0, 1, right? After 0, 1, it goes to what? And 1, 1, when you clock it, it goes back to 0, 0. Got it? All right. So now, let's think about how we're going to fill in the J1, K1, and J0, K0, okay? Let me just clean this up here for you just a little bit, all right? All right, now, first off, we need the JK flip-flop excitation table written down, and you already know this. So if you have a transition from 0 to 0, what's going to cause that? Well, there's two states that's going to cause it. And by the way, this value, this is Q. It's not Q bar, this is Q, okay? So that's the output we're talking about. So if Q is 0 and it gets clocked and it stays on 0, what's going to cause that? It's going to be when J and K are both 0, that's the no change state, or it's in reset, which is 1, 0, right? So if you notice, J must be a 0. I'm going to call this J right here. And your K, that can be either a 1 or a 0, right? Got it? So that's an X0. Get it? Now, what if we're going from 0 to 1? What's going to cause that? Well, two things, right? You can toggle it, Remember what toggle is? It's a 1, 1, right? Or you can set it. A set is a 0, 1, right? Which means J would have to be a 1, or K could be either a 1 or a 0. It doesn't matter. So that would be 1x. Get it? How about a 1 to a 0? How would you do that? Well, obviously you could toggle it, right? They're changing states. You can toggle it. Or you can reset it, right? That would be a reset. There would be a 0, 1, right? Now if you look at that, that would be a, got it? 1x would be x1. Okay. And now 1 to a 1 is the next one, the last one, right? Actually, well, that could be, what would do that? It would be 0, 0. That's no change, right? You clock it, nothing's going to change. Or you could set it, in which case a set would be a 0, 1, right? So that would be an x, and that would be a 0, right? Got it? That's your excitation table. Okay? So, that's for a JK flip-flop, okay? So, we can actually, let's just leave it that. So it's not in the way right now. We'll just leave it there for now. All right, everyone. So let's fill in this table, shall we? It's a state table. So let's look at this. We're going to be going, let's look at Q0 first. A transition from Q0 equals 0 to Q0 equals 1. Get it? And if we look at that, that's this transition right here, right? We're going from a transition of 0 to a transition of 1. And that is x1, correct? So that is simply going to be x1. There we go. The next one. Well, look at this. 0 to 0 transition, right? Q1 is going from 0 to 0. Well, we know where that transition is. It's right here, and that's going to be x0, right? So let's try it. Next, let's look at this one. We're going from a 1 to a 0. You're always going from present to next, all right? That's how this works. We're going from a 1 to a 0. Well, that's this one, which is 1x. Okay. And then we're going from a 0 to a 1. We've already done that. That's an x1, right? Got it? Now let's try the next one. You're going from a 0 to a 1, 0 to a 1, that's x1. Now we'll look at Q1, that's 1 to a 1, that's this one down here. That's going to be 0x, isn't it? Now finally you have a 1 to a 0 transition, right? For both states here. You see that? So the transitions are going to be the same. We're going from a 1 to a 0. And we look at that, that's going to be 1x, isn't it? Alright. Beautiful. There you have your state table, right? Now, let's draw the Karnaugh maps. This is what you have to do. So I'm going to remove this state table here, okay? Now, have to put in 4 Karnaugh maps because we have 4 variables. There's 2 J's and 2 K's, right? So there you go. 1, 2, 3, 4. And each one of these is a Karnaugh map. It's a 2 by 2, right? 1, 2, 2. Okay. Next. This is going to be Q0, Q1, Q0, Q1, 0, Q1, Q0, Q1, right? Now, each one of these has to represent something, right? Let me just see if I can pull this down just a tad. A little bit of space up here. So, this is going to be J0. This Karnaugh map over here is going to be K0. This Karnaugh map down here is going to be J1. And this is going to be K1, right? So let's fill them in, shall we? This is going to be 1. I'm sorry, my fault there. 0, 1, 0, 1. 0, 1, 0, 1. 0, 1, 0, 1. 0, 1, 0, 1. Okay, now it's ready to be filled in. So let's look at J0, okay? And that, I'm going to fill these in blue, all right? It's this column right here, all right? So, when Q0, I'm going to erase these so you know exactly what I'm talking about, okay? We are referring to the present column, all right? That's what we're referring to. Now, let's go back here. If we're in this column right here, all right, when Q0 and Q1 are both 0, that means we're going to be in this cell right here, okay? Because they're both 0, right? Q1 is 0 here and Q0 is 0 up here. Got it? So when they're both 0, J0 is going to be, or J0 is going to be 1. There's your 1. Okay? Now, let's look at this one. When Q0 or Q0 is 0, okay? When Q0 is a 1, which means it's going to be over here, right? Because here's your 1. And Q1 is 0, that's going to be in this cell, right? And you come all the way over, J0 is an X, isn't it? Now let's do the next one. When Q0 is 0, okay, it means you're in this column right here. I think it's going to be that cell. And Q1 is a 1, that means you're in this cell right here, okay? Q0 is a 0, Q1 is a 1, you're in that cell. The value that goes in there is a what? 1, right? And finally, when they're both 1, means you're in this cell here, right? When they're both 1, J0 is equal to an X. Get it? Now, let's do the same thing for K0, which is this column right here. It's going to be the same thing here, right? X1, X1, right? Now let's do it for J1 and K1. Here's J1, we'll do this column right here. That's going to be 0, 1, X, X, right? And finally K1 is right here. That's going to be X, X, 0, 1. All right? Fantastic. Now, let's get expressions for each one of these, shall we? So, I'm going to write the expressions in red, okay, just to give it a different color for you. So, in this one, J0, first we got to group them, right? Well, you can easily see that you can group the entire thing. If both of these x's were 1s, you would have 4 1s there, right? So you could just simply group them. And that would mean, what would that mean? That would mean J0 equal 1, right? Guess what? The same thing. You can do the same exact thing here with K0, right? If the two x's make the two x's 1s, it's a matrix of 1. You have 4 1s there. Group them all. That means K0 equals 1, right? That's nice, huh? Now let's do J1. Suppose we make this x down here a 1. That means we can do that, right? Now this x, I would make it a 0 because we don't, it's not going to help us, so I just keep that as 0. Now guess what? This one, for K1, I would make a 1 as well. So notice it's the same grouping for both of them, right? That's why I did that. So now J1, what's it going to equal? Well, if you look on the side here, it changes, right? It goes from 0 to 1, so we discard Q1. So it's going to be when Q0 is going to be equal to Q0, right? Now guess what? K1 is the same thing, isn't it? Now, if you've forgotten some of this about Karnaugh Maps, there is a video. I already did a video on Karnaugh Maps. You can go back and review that. But now we're actually using the Karnaugh Maps in these tables to generate circuits to do things. This is very powerful, right? You have a powerful tool here. Okay, so now let's make the circuit. So if you notice, we have two Qs, right? We have a Q0 and we have a Q1, so there's two of them. So we're going to need two flip-flops here, right? Here's one, and here's one, okay? You know what? Let me just pull those over just a little bit to the left just to give us some space here. Okay. Now, let's start filling them in, right? Here's your J, here's your K, here's your J, here's your K. Didn't draw that too well, right? Now we're going to call this one 0. Let me draw that in blue for you. This is going to be flip-flop 0, and this will be flip-flop 1, okay? So we're going to have, this is Q naught here, right? And this is going to be Q1. I'm not drawing the Q bar because it's not used. We don't use that output. So let's just see. This is 0, so that's J0, K0, and this is J1 and K1. Okay? Now, in each one of these we have a clock, and they're connected together. I'm going to do that at the end because it could get, the drawing could get a little messy, and I want to make sure you understand the pertinent parts of this circuit. First off, we said J0, if you look over here, J0 and K0 both equal 1, right? When something is equal to 1, that means it's detached to VCC, okay? It goes right to power. Now J1 and K1, remember this is Q naught right here, Q0. J1 and K1 are both equal to Q naught, right? So there's your input right there, you see? Now look, what about your outputs? I'll bring it up here for you. So this is your Q0 output right here. And here's your Q1. Now, these two clocks, they are going to be attached here to your master clock. Okay? I didn't draw your presets or your clears. Alright? But those are self-evident. Alright? But there is your circuit, and this is how you had to do it. Remember, you had to start with your timing diagram. From your timing diagram, you filled in your present and next state on your state table. This is your state table. That's 2, right? Then you used your excitation table to fill in your synchronous inputs. I'm going to say that's 3. Then you developed Karnaugh maps for each one of these inputs. That's 4. You solve them to get an expression, and then from these expressions you built your circuit, right? Now, there could be other steps that a textbook might have in there, but you generally get the idea. That's what you're doing. You just made a circuit, a counting circuit. Fantastic. Alright everyone, I hope you enjoyed this adventure, and I will see you on the next video. Bye now.